Okay, this is section 2.8 for MAC 1105, and in this section we're going to be finding the distance between 2 points, the midpoint between two endpoints, equations of circles, and also we'll be graphing those circles. So in the first problem, it's a formula that's probably pretty familiar to you. It pops up in a lot of math classes even before MAC 1105. We're given 2 points, -3, -2, and 1, 6. By the way, I've given you examples where you have to use the distance formula, because if you have two problems that are 2 points that are vertically aligned, you'll just be able to count the distance with your finger. If you have 2 points that are horizontally aligned, you'll be able to count with your finger. But most of what you're going to be given will be 2 points where neither the x's match nor the y's match. So you're not in a vertical situation, and you're not in a situation where the points are horizontally aligned. So you have to use this formula. So since we're trying to get practice on this, here we go. We're going to follow this formula, set everything else up first, just so you don't miss out on any negatives or anything or any symbols that are in the problem. In the first parenthesis, you're going to put your two x values. You're going to find the difference. You're going to square. Then you're going to add that to the same, doing the same steps, but for the y values. You're going to subtract them. You're going to square them. Always working, and we'll put a little note under here that we're going to put our x's, and then here we're going to put our y's. Always working towards a single number in here, which you will then try to simplify if possible. Once you establish a direction that you're going to move in, you're either going to move in a direction where you're starting on this point and ending on this point, or vice versa, but remain consistent. Don't move in one direction for the x's and then change your mind in the middle of the problem, because that is not what this means. Again, a lot of students think numbers at what you probably think is the second point. What this really means is that you just have two different x values. They're not telling you where to start, and I know many students think that. The way you can prove that it does not mean that, try doing the problem either way. I'm going to start with these numbers and then go and grab these numbers, but you are more than welcome to do the opposite of that, and you'll see you get the same answer if you don't make any errors. So the x's here, I'm moving in this direction, and that'll be your choice. I'm going to use -3 and then 1 as my other x value. So -3 and +1 as my other x value. Moving in the same direction when I go grab the y's, I'm going to use -2 and 6. Okay, now continuing to clean this up. -3 take away 1 is -4. -4 squared is 16. And then let's work on the y's. -2 take away 6 is -8. -8 squared is 64. Whether you square a positive or a negative, you're multiplying the number and its sign by that same number and sign again. That's why they never come out positive. They never come out negative. So this always comes out positive. Now we're going to go further. We're going to go all the way until we have a single number. So when you add 6, that would be 80, 70, 80, all of this happening underneath the square root. So right now, we're at a point where we have square root of 80. I also gave you one where you could practice your skills in reducing an imperfect square. This is not a number that is a perfect square, so the entire thing is not going to come out from underneath that radical. However, you can take a partial square root. Try to find a number that divides into this, because we're going to break this down into two factors. Something times something that equals 80. One of them you want to be something that there's a square root of. Now I know 4 goes into this, but is there anything bigger in the list of things that we know the square root of? Don't bother with 1. The next largest number after 1 that there's a square root of is 4. This is 1 squared, 2 squared. There's a square root of 9. This is just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Any of these numbers, and the list goes on, are good for breaking down imperfect squares. The larger the number you can find that goes into it, the less steps you're going to have. So like I said, yes, 4 does break down an 80 for you, but then you're going to have 4 times 20, and the 20 is going to have another 4 inside of it that you'll have to take the square root of. So I would try to, look a little further. 16 does divide into 80 5 times. So right now we're just finding a different way to write 80, 16 times 5. All of this is happening underneath the square root. We're trying to see what we can take the square root of, and we can take the square root of just this part. That's why it's called a partial square root. We don't want decimals here. We want exact answers to begin with, and then if they additionally want an approximate answer, then you can go on to get that. But you have to have the skill of taking partial square roots if you're going to give an exact answer. So here's a 16. We're taking the square root of 16, so it comes out as a 4. So we're done with that. There is no square root of 5. And it's a prime number, so you can't break it down any further other than to say 1 times itself, and that's not going to help any. So this is your exact answer. Now, if you want to get an approximate answer, and they have said to approximate it to the hundredths place. If you want to approximate, then you just put it in your calculator. And I would probably go right from here, because otherwise you're going to have to go 4 times square root of 5, and that's just more things to enter. So you could just go from its original unreduced state. Get the same answer either way, but why not make it easier on yourself? So there's square root, close it, 80. You're going to go to the hundredths place. That means go out 2 numbers past the decimal. That's a tenth, that's a hundredths place. So that rounds to 0.94, 8.94. Okay, so you are giving an exact answer showing that you know the algebra of reducing an imperfect square, removing a partial square root. And then in your approximate answer, you're just putting it in the calculator. So not really showing any algebra skill, but for some application problems, it makes more sense to be able to state the answer as a decimal. So we want you to have that skill as well. Okay, next is the midpoint formula. And in the midpoint formula, you have 2 points. You have a point maybe here and a point here. This would be, let's say this would be x1 and y1. And then you'd have some other point here. So you have 2 different x's, 2 different y's. And what you're doing is you're finding the point right in the middle. So that middle point, let's say that the x-coordinate is called the x-coordinate of the midpoint, and the y-coordinate is the y-coordinate at the middle. So that is what this formula is for. When you do x1, when you add the x's on either end and then cut it in half, you're making yourself land halfway in between the 2 ends. So we'll call this the way that we find the x-coordinate at the midpoint, and this will be how to find the y-coordinate at the midpoint. So here we go. I have purposely given you some numbers that you have trouble with. Most students can handle the integers just fine, and then with the fractions they struggle. So we need to practice on the things that we struggle with. Okay, so let's go to the x-coordinate. Follow this formula, which is add up your x's in whatever order you want, and then cut it in half. Okay, so one of my x's is -4/3, and my other x is -8/3. And then eventually I'll be cutting that in half, but why don't we just continue to work on the top? Okay, so luckily for us, both of these fractions have the same denominator. So when they have the same denominator, you just copy that common denominator, and then you add the top. So this is -4 plus -8. You can put that in your calculator if you want to. It's -12. Let's continue with the top. -12 divided by 3 is -4. And then we'll copy that divisor. The divisor happened to be 2. Now we're looking at the top number divided by the bottom number, -2. That is the x-coordinate at the midpoint. Okay, we'll collect these answers together in a minute, in the form of a point. Let's find the y coordinate and cut it in half. Okay, those y coordinates that we're going to add at the top in the numerator are 5/3 and 13/3. Okay, 5/3 and 13/3, then it's divided by 2. Let's just continue working on the top instead of hopping back and forth from numerator to denominator. Okay, so let's see. They're both same denominator, so in that case, just copy the denominator, but add the tops, the numerators. So 5 plus 13 is 18. Keep working on that top because you can still reduce it. So 18 divided by 3 is 6. Then bring that denominator of 2 all the way over, and 6 divided by 2 ends up being 3. So in the end, the midpoint with both coordinates collected together in the form of a point would be the x is -2, while the y is 3. Plus we got to brush up a little bit on our fractions. Okay, moving to the next page, we start to talk about the equation of a circle. This is the standard equation of a circle. This is the formula for writing the equation of a circle when it's in standard form. So all you're going to do is, you're not plugging in any of these equations for x and y unless it has a little subscript hanging from it. So you're not plugging in for x and y. You will just literally write x and y. You're going to subtract the h coordinate and the k coordinate. That's really just the x and y coordinate at the center. So you're going to look for those two numbers at the center, the x and the y coordinate. They just happen to be called h and k, and that's what you see them plug. Don't forget to write x followed by a minus sign for both of these parentheses. And then whatever you plug in might cause a double negative, and maybe it won't. Okay, so here we go. We're going to get ourselves ready by writing the formula first for the equation. Let's get ourselves all ready. Write that shell, just like when I did the distance formula, when I did the midpoint. It's x minus whatever you're going to plug right in there, which that's a little space for your h value, plus, then it's going to be y minus whatever you're going to plug in for your k value. A little k value will go there. Then it's going to be squared. All of that information is given right here. It says the center of the circle is -3, 1. This x value stands for the h. This y value stands for the k, what they call h and k. So h goes right here. It is a -3. The k value goes right here. R value's 2. And then clean that up a little bit. You're not going to FOIL it out or anything. You're not going to square it out. Just clean up any double negatives and maybe square out that number. So double negative here, that would be the same as a positive x plus 3 squared. You don't actually need to square it out because you're being asked to give it in its standard form, which looks like this. So if you squared it out, it wouldn't look like that anymore. There were no double negatives here, so just y minus 1, and then 2 squared, of course, is 4. And that is the equation of the circle. So I don't need to write it again. I wrote it up there. Now if you want a graph, which they also ask you to do in this problem, you can just go right from this information. All you need is the center and the radius to get the full circle. This is not something that you would put in your calculator, although there is a way to put it, but it'll take you 3 times longer than if you just graphed it by hand. Always graph the center first. So just go to -3 up to 1. And then that radius is the distance that you stretch out in both horizontal directions as well as in both vertical directions to get the outer circumference of the circle. So we're going to stretch out 1, 2, plot a point on the outer rim of the circle. Stretch out 1, 2, another point, 1, 2 in this direction, and 2 units down. So that would be 1. Right there. And then in the end, Just connect all the points on the outer rim of the circle to give yourself a nice circle graph. Okay, and there's your circle. Okay, and problem number 4, it says, given the equation, and let's see if there was any more questions here. I think I missed one question. Also graph the circle. Oh, there was this question. Is 3 -4, is 3 -4 a point on the circle? If you don't know how to, if you don't understand what that means, that just means on the outer rim of the circle. So let's see. Let's go to -3, 4. If we went to -3, and then we went up to 1, 2, 3, 4. Do you see that we would not be on the circle? So is this a point on the circle? No. So we've answered everything there. And this, by the way, this is the kind of question that, when you're doing the problems, if you're using the technology that was built with these outlines, there's questions that you have to respond to. And if you are using that in the particular class that you're in, you would need to be responding to some of the questions by actually graphing, and then some question would be asked with regard to the graph in order for you to know whether you're on the graph or not on the graph. So you always want to graph if you're asked to do that. In problem number 4, this has to do with graphing again. It says, given the equation of a circle, here it's already in the form that we worked towards getting in problem number 3. You can see what the h and the k is. Now remember, the formula goes like this. It goes x minus the h value, and then they put the square on there. And it goes y. This should have been a y. Please fix that. So then it goes y minus k squared, and is equal to r squared. So if you're comparing what you're seeing here to the actual formula, the actual equation formula for a circle, then you got to think to yourself, what could they possibly have plugged in for h that would end up looking like a +1 after you plug it in right here after a minus sign? Wouldn't that have to be -1? Because that minus will switch whatever you're plugging in for h. So they must have plugged in -1, that minus sign switched the -1 into +1. So that means h is -1. Likewise here, what could they possibly have plugged into this circle equation in order for it to end up looking like a -3? It would have had to be a +3. They would have to be the opposite of what you're seeing here. Because if you put a +3 in, the minus sign is what makes it into a negative. So the k value had to have been a +3. Okay, so -1 must have been plugged in there to make it end up looking like that after applying the minus sign. And a +3 had to be plugged in there in order for it to look like this after applying the minus sign. As far as what must have got plugged in and then squared to give you 9, well, go the opposite way. Take the square root of this if you want to know what the r value is. So r happens to be 3. So sometimes you'll be asked to give the equation, sometimes you'll be asked to understand the equation and think what must have got plugged in for h, k, and r in order to end up with this equation. And all you'll have to do is look at the values that you're seeing in here, switch that sign, that's h, switch that sign, that's k, take the square root of the number you're seeing there, and you'll be right back to the r value. So it says, identify the center. The center is always known as h and k. So in this case, -1 and 3. And then identify the radius. We've already identified the radius. And then if we wanted to use the information to graph the circle, again, you always start at the center. So -1, 3 would be right there. And then we would use the radius to find points on the outer perimeter of the circle. Or not the outer perimeter, but the outer circumference of the circle. So we would go 1, 2, 3 this way, 1, 2, 3 this way, and then we go 3 up, 1, 2, let's just go a little higher, and then 3 down, 1, 2, 3. And then you have things that are on that outer rim of the circle. And you got a nice circle there. Okay, then it asks, which of the following points are actually on the rim of the circle? So in this circle, let's see, if we went to negative 1, 6, we went to negative 1, and then we went to 6. 1, 2, 3, 4, 5, 6. Yep, that one is on the actual circle. If we went to negative 4, 4, we went to negative 4, and then we went up 1, 2, 3, 4. You're not actually on the circle. This point's on the circle, but here you would be jumping outside of the circle. Mine may look like it just because I didn't draw a perfect circle, but that point would actually not be on there. Okay, so this is no. And if you went to negative 1, 0, you would go to negative 1, right to 0. You could see that that was one of the points that was actually on the graph, so this one is also on the circle. Okay, moving to number 5. And you know, like for this one where we answered no, if you're ever not sure whether or not the point's on the circle, you could always plug it into the equation. I mean, this is the equation, x plus 1, just if you needed a way to check it, x plus 1 squared, because you're just kind of not sure whether it's on there or not. Okay, so that was the equation. We wanted to know if negative 4, positive 4 is actually on the circle. This is just an XY pair, which means you could plug this in for X, plug this in for Y. You could plug the negative 4 in for X. You could plug the positive 4 in for Y. And you can see whether it produces a true statement or not. If this point, negative 4, 4, the one that we said no to, if that point is, if it really is on the graph, then you'll get the same number on both sides. You'll get a true statement. So let's see what we get. We would get, here we would get negative 3 squared. That ends up being 9. And then you can already see it's not going to happen. You're going to get 4 minus 3. That would be 1. 1 squared is 1. No, these sides are not equal. On one side you have a 10, on the other side you have a 9. So we did answer properly that this point is definitely not on the circle, while the other ones were. Okay, moving to problem number 5. Problem number 5 is where instead of being in standard form is the form of a circle equation that we just looked at, the one that went x minus h squared plus y minus k squared is equal to r squared. The previous two problems, numbers 3 and 4, we're using that standard form. Now we're in general form, where all terms are in one side set equal to 0, and you're going to be trying to get it in standard form, because you need it to be in standard form if you're going to try and graph the circle, which you are asked to do here. So there was a method that's called completing the square that we did back in probably section 1.5, chapter 1. We were using it as a solving technique for quadratic equations, but it can also be used when you're studying, you know, various conic sections and you're talking about circles and parabolas and, you know, whatever you happen to be talking about. And you can use this completing the square technique to find the vertex or the center of the shape that you're trying to graph. And so that's what we're going to do. We're going to be using those steps. So here we go. Let's do a review of completing the square. First of all, you have to arrange all of your X family members together. And you can only complete the square on that particular family if you have a squared term and a linear term, both belonging to the same family, which we do. We have a first degree term and we have a second degree term. We're going to complete the square on this family. Let's leave it like that for right now. Now let's get all our Y family members together. We have and you can put a plus sign in between the X family and the Y family. Let's group all the Y terms together with a squared term. And we do have a linear term, both belonging to the Y family, so we will also be able to complete the square on this Y family. Then, let's see. All right, so we did those two in one parenthesis. We did the Y squared and the 6Y. You're going to want to get the constant. If you remember this completing the square procedure, you get the constant on the opposite side. So you'll have your variable families together. You'll be able to complete the square on anything where you have a squared and a first degree term, both in the same family. And whatever you add into this space, you'll be adding a brand new number that didn't exist in the original problem. So remember, this is a balanced equation, balanced statement. Any equation's balanced, and whatever you do to the left, you must do to the right. So we'll be adding to this number over here. Okay, here we go. The steps, if you recall, from chapter 1 for completing the square is you go to the linear coefficient, you cut it in half, which is -2, and then you square it. Cut it in half and square it. And that number that you produce will complete this family. If you're going to add 4 to this side, this left side of the equation, you have to add 4 to this side. Okay, then if you recall, we then would take this perfect square trinomial that we just created, because it used to be a binomial, now it's a trinomial. And we created it through completing the square, which makes it classify as a perfect square trinomial. All of those perfect square trinomials factor like this. And when you factor it, you'll start to see that it looks like the standard form equation of a circle that we were studying on the previous page. When you're trying to factor perfect square trinomials, you take the square root of this front term, I'll call it the first square root. You take the square root of the constant, I'll call it the second square root. And then you join these two terms by the sign that you were working, the sign of the term in the middle, the linear term. And then you put a square on it. All perfect square trinomials factor like this. You don't have to use guess and check or the splitting the term method. There's just a shortcut available for factoring this particular type of quadratic trinomial. And that's take the square to the front term, take the square to the back term, join these two terms by the sign of the linear coefficient. Okay, likewise, let's do the same thing here. Let's complete the square, get it factored. Remember that any number you add in here is brand new, wasn't in the original problem. So if you add it to complete the square, you have to add it on the other side as well. Okay, working on the Y family. Cut that linear coefficient in half, we get 3, and then square that number. And we get, let me write that a little bit clearer, and we get 9. So we're going to be adding a 9 into this family and a 9 on this side. Okay, so again, we added this 9 to complete the Y family and therefore added 9 on the right-hand side as well. Okay, let's take this family, this new perfect square trinomial that we just created, get it in factored form. All perfect square trinomials factor like this, and you fill in the front and the back just by taking the square root of the first term, square root of the back term, and join them by the sign of the linear coefficient, which was plus. Okay, tally up all these numbers, combine them. This canceled with this, you're left with just a 9. You now have an equation of a circle that is in standard form. This is the standard form of a circle equation. And when it's in that form, you can tell what the center is. Again, let's compare it to the equation that I introduced on the previous page, which went like this. X minus h squared, this is the standard form, we just got it in this form, plus y minus k squared is equal to r squared. Because by taking your answer where you completed a square and comparing it to the standard equation for a circle, you can tell what the center and the radius is. So the center, okay, think about what number must have been plugged in right here, being that there's a minus sign, for it to end up looking like that. It would have to have been a positive 2. And then what number got plugged in here, being that there's a minus sign, that would end up looking like that. You would have had to have plugged in a negative 3 here, and then that minus would take the negative 3 and turn it into a positive 3. So basically, they're just the opposite of what you're seeing here. What number could you have squared to get a 9? That would have to be 3. And by being able to extract this information from the standard equation that you just created by completing the square, you're able to graph it. So now with this information, you go and graph it. Okay, so you always do the center first, so it's positive 2, negative 3, 1, 2, 3, and then to get points on the edge of the circle, not the edge of the circle, but just the rim of the circle, you're going to move out 3 units, 1, 2, 3, then 1, 2, 3 in this direction. You're going to go up 3 units, 1, 2, 3 in this direction, and 1, 2, 3 in this direction. And then just connect all those outer points to get the full circle. Okay, they don't ask any other questions here, not specifically like, are these points on the circle? That means, are they on the outer rim of the circle? That's not asked here, but you were practicing the procedure of completing the square, turning 2 terms into a 3-termed perfect square trinomial, which is then factorable like this. And once you got it factored, it turns out that it is now in the circle equation form called the standard form, which is what we were talking about in all the examples on the previous page. And that allows you to identify the center and the radius, which is the information you need in order to end up with a graph. Okay, that completes section 2.8 for chapter 2. And that is the end of this chapter.